Reciprocal of linear function. I'm Anil Kumar, and now let us do Unit 5, which is rational functions, and the first chapter in this is reciprocal of functions. Now, linear function is a very basic function which helps us to understand all the concepts which we need to know about reciprocal of functions. So let's begin with a straight line. So here on a graph we have a straight line, and we'll call this the function f of x, and we also sketch a reciprocal of this function. Let me call it for the time being r of x as a reciprocal function of our linear function, correct? So let's analyze the line itself. On the line we have y-intercept of 2, and the slope is, if we consider these 2 points, rise is 2 and run is 1, and therefore we can write the equation of our function as f of x equals 2, slope is 2, so we can write this as 2x, and y-intercept is 2 plus 2. That is the equation of the function. So we are considering here a linear function, right, whose equation is 2x plus 2. We're calling it f of x. And the reciprocal function which we are dealing with is r function. We'll call it the reciprocal function. Okay. And the equation for this reciprocal function will be 1 over f of x. So we'll call this as r of x as equals to 1 over 2x plus 2. Correct? Reciprocal is 1 over f of x. So that becomes the reciprocal function's equation. So reciprocal will write r of x is actually equals to 1 over f of x. So by definition, reciprocal is 1 over the function itself. So that is by definition. Now let us look into some characteristics of both these functions. We'll begin by the point where they intersect. Okay, so the point where they intersect is where the y value is either 1 or minus 1. Do you see that? At these points y value is 1, and here y is minus 1, right? These points are called invariant points, right? They are exactly same points on both the functions. Do you see that? So we have, when you notice these graphs, we have invariant points. Let me write down here amongst the characteristics. The y, if f of x equals to 1, then r of x is also equal to 1, correct? Since 1 over 1 equals to 1, correct? Also, if f of x equals to minus 1, then the reciprocal will also be equals to minus 1. So their values are exactly same. Do you understand? Since 1 over minus 1 is also minus 1, right? So these points are called invariant points. So these are called invariant points. So let me write down here itself invariant. So invariant points are points which are common for both the graphs, right? They don't vary, okay? So this graph, this point is going here. And in reciprocal function, the y value is 1 for them. Therefore 1 over 1 or 1 over minus 1 is the same, right? Invariant points. Now, so these are the points at 1. So let's look into the linear function. As we go away or higher values, where y values are more than 1, what happens to the reciprocal function? They become lower and lower, correct? So as f of x increases, goes away from 1, the reciprocal becomes closer and closer to x, correct? Before that, what we also notice here is that whenever f of x is positive, do you see this? From here onwards, f of x is positive. On this side, f of x is positive. So if our linear function here, f of x, is positive, in that case the reciprocal function is also positive. Do you understand? 5 and 1 over 5 both are positive, correct? If f of x is negative, in that case r of x is also negative, right? So the lower half, see the quadrant 3, when f of x is in quadrant 3, then r of x, the reciprocal, is also in quadrant 3. That's what you can notice here, right? When f of x is greater than 0, r of x is also greater than 0. Okay, so that is what it is. So these are very important points to consider. Now another thing which we'll notice here is that when f of x is approaching positive infinity, then r of x is approaching 0 but from positive side. As f of x is increasing, do you see that part? Then r of x is decreasing and approaching positive infinity, correct? But when f of x is approaching negative infinity, that means this side, right? Then then this side, then reciprocal is approaching 0, again approaching 0, but from the negative side. So you can combine these two. When f of x is negative, r of x will be negative. Approaching high value, they are approaching lower values, correct? Now, there's one critical point here. When f of x is equal to 0, then what happens? Now that is a very critical point, and we will highlight this. Now we know when f of x is 0, then what is r of x? R of x will be equals to 1 over 0, that is undefined. Correct? So at this point we have a vertical asymptote. So I'm drawing it with a dotted line. The reciprocal function is not defined at this point. It is not in its domain, correct? Undefined. So we say that r of x is undefined, however its value is approaching either positive infinity or negative infinity, depending on which side of the curve you are, correct? So if f of x is approaching 0 from positive side, it approaches positive infinity. If you're approaching from negative side, it approaches negative infinity, right? So if you're approaching from the negative side, then the reciprocal function approaches negative infinity. Do you see the point? That is how, this is a very, very critical characteristics which you need to observe, right? So that brings us to almost all the characteristics. And one thing which you also notice here is that f of x is a polynomial function, right? So this we have as a polynomial function. Let me use some different thing. Then reciprocal of a polynomial will be a rational function. I hope you appreciate that part also. It is 1 over the polynomial, so it becomes a rational function. What you also observe here is that in the domain of your linear function, the domain is x belongs to real numbers, where there are no restrictions. However, here the domain is restricted, so x belongs to real numbers, but x is not equal to wherever this function is 0. In this case, the function is 0 at -1. So in this case, it is not equal to 0 at -1. Do you get the point? In the range also, for the polynomial function, y belongs to real numbers, but here we have a restriction. Y belongs to real numbers, but y is not equal to 0. Do you understand? Y is not equal to 0. So that is again a restriction. Correct? So in a reciprocal function, you'll find a restriction. And two other things which you find in reciprocal functions are, it is approaching, it is not there. Do you understand? So when it approaches horizontally at this point, we call this as horizontal asymptote. And when it is approaching vertically, we call that vertical asymptote. So a reciprocal function can have, I should not say will have, for linear function, reciprocal of linear function will always have, right? If it is not a horizontal line in that case, right? Horizontal lines are different. So we are treating horizontal and vertical lines as different from general linear functions, okay? Now, important thing here to consider is which we call as asymptotes. Reciprocal functions will have asymptotes, which will not be there in polynomial functions. So they are approaching a value, but they are not right there. So when x value is increasing to a very high value, positive or negative, reciprocal function is actually approaching a value but never being there. In this case it is approaching 0. Then we call that as a horizontal asymptote. But when the function is approaching 0, at that time reciprocal function is approaching infinity, and that results into a vertical asymptote. Reason is 1 over 0 is not defined, correct? So these are a few things which you have to consider when we are learning about reciprocal functions. Okay, now these horizontal asymptotes, we also link those horizontal asymptotes, let me write here, for our reciprocal function, as we say that the y value is approaching, right? So we say horizontal asymptote is y equals to 0, right? It is approaching 0. And when we are saying that minus 1 is not in the domain, at that time the function is approaching infinity. Here we say the vertical asymptote is x equals to minus 1, the value which is not in the domain, right? So these are additional things which you are going to learn and explore while we do reciprocal functions and thereafter rational functions. So reciprocal of a linear function is a very important function for you to understand. Go through this video and try to understand all these terms, correct? And we will now explore in coming videos behavior of the reciprocal function near the asymptotes. Okay, we'll discuss that in a different video. And horizontal asymptotes are also end behavior, right? So we'll link that to end behavior of our function. For line, we know the end behavior as x approaches infinity, y approaches infinity. For this, as x approaches infinity, y approaches 0. So that is the end behavior, right? As x approaches negative infinity for the linear function, y approaches negative infinity. But for the reciprocal function, as x approaches negative infinity, y approaches 0, right? That's the end behavior, correct? So these are the terms which we'll keep in mind when we study more about linear functions. I hope that helps. Thank you and all the best.